A inverse times B would have to equal C, right?
No, C could be any matrix at all, but C depends on whatever your transformation is. You can have any number of transformations. You know, you have an infinite number of choices for what this transformation is, but there's only one matrix that represents it.
Right.
Okay? Now you're still working through that, I'm sure, but you know, that's where we are with this, okay? I mean, you just finished your test. I know you've been slacking on the stuff. No, you haven't been slacking. You've been keeping wolves away from the door and all that stuff. Okay?
Yeah, nice.
Not what you ought to do, but sometimes life makes it that way. So you might be a little behind in understanding the preceding stuff in chapter 5, 6. Okay? But you got to put it together because we can't stop and wait.
Yeah. It's
You know, the alternative would have been, say, the test is due Monday. Okay?
Yeah.
Got to give you time. And hope you make good use of it.
We had a nice little study session last night. Came out feeling a lot better.
Good.
Both of us felt a little bit more solid. Yeah.
Okay. Well, okay, what it comes down to, because we're almost out of time, and I do have Lee and Will wants to come by and talk for a minute. Okay. Well, if VB hat equals this, and WB hat equals this, right? And it's B hat. Tap tilde, okay? Make sense? Well, it looks like we can tell what V is if we just multiply both sides by B inverse A. Okay, so, yeah, we'll go on. Write that, certainly. Okay? Okay, well, what does this side come out? And there's no D in there. See, it's much simpler now.
B is just 1 and A times A inverse is just 1, right?
No, matrix times a matrix isn't 1. It's an identity.
It's the identity.
Yes, that's what you meant. Okay, so on the right-hand side, you got WB. Sorry, WB hat, right? What do you have on the left-hand side? We got this mess, right? Well, I'm going to call this
Use some constant, right?
P inverse DP, where P equals A inverse B. You take the matrices that represent the two bases, you put them together like this, and you get your P matrix. Okay? So now you have this. And this is what we call a similarity transformation. And I forgot that we have our V hat over here, right? But and I think I did something wrong. Yeah, I've got my hats in the wrong place here. Because VB hat, which is here, is A inverse V, B times VB. So I shouldn't have had my hat on there. Shouldn't have used the tildes. Get rid of the tildes. Okay. And what do I have? I've got the matrix that multiplies VB to get WB. And what's that? Okay. So here's how we get one matrix relative to the other. Of course, if we know D and want to get C, we just multiply by P on this side and P inverse on this side. Very simple. Okay? And it comes down to something very simple. You just put the matrices, you just put the bases in columns and do this, which probably isn't what your book says. It's what it should say. You can see what your book says and compare with what I'm telling you. Okay?
Okay.